So I just wanted to start out by thanking all of you to have me joining you remotely, and I'm sorry I was not able to make it over there to be in person. This session is about new ways that we can approach our diagnoses, both with patients and with regulatory systems. And this is about a new idea called the research diagnostic criteria to see how we can move forward in looking at research and how research can be integrated with actual clinical treatments and assessments. So the title here is the Research Domain Criteria Project as a Framework for Precision Psychiatry. Can go next. I assume that you'll have to do the next, you move them along. As you can see, there are no conflicts of interest, and these opinions that are expressed are not those of the speaker and do not necessarily represent the views of the NIMH, et cetera, in the government. Next. So to start, I'd like to talk just a little bit with the introduction about the diagnostic issues that we have for research from DSM-3 and after. We've heard this before, but I just need to set this up in terms of RDoC, as we call our project. Next. I think that the DSM, in fact, did bring psychiatry into the modern era from the analytic periods of the early 20th century, and so it's made excellent progress. However, we have finally started to realize that the DSM-3 pattern and the ICD as well, that is similar, are kind of running out of gas in terms of how we can actually use them. So just to summarize this, the DSM and ICD are all based on clinical symptoms and signs, as we well know. Next. And these were devised for reliability, but not for validity. And this is not surprising because it was not feasible to have any validity at that time because there were essentially no kinds of data that could be used to look at the validity of different kinds of disorders. Rather, they were put into play for the best ideas that people could use with different disorders going back for a couple of decades in Washington University and other places to say, what can we think about that makes sense here? Once the DSM came into play, things changed. The DSM-3 actually had some caveats saying that, for instance, disorders are not real diseases. They are we have the symptoms for them, but they're not all the same. Each person could have some kinds of different aspects. Also, one disorder is not necessarily distinguished from another. There may be some overlap and so forth. However, I think in the excitement and the utility of having the new DSM-3, the disorders became reified. That is, out of these concepts of disorders, they became treated as real diseases. And this became a problem because everybody felt that, okay, this is what the disorders really are, and this is what we are trying to cure. And as the 45 years have passed since the DSM-3, just a year short, we have observed the heterogeneity, the comorbidity, the not otherwise specified diagnoses, and so forth. Next. We also realize now, as we've been discussing throughout the conference, that the disorders are really dimensional, not simply a binary distinction between ill versus well. Next. And coming back again, we've realized more and more that we have had a failure to establish any kinds of biomarkers, and this has been discussed this morning as well, of course. In another way to put that is simply that there is a lack of validity. And so RDoC was started by Dr. Tom Insel at NIMH around 2009 in order to try to do some efforts to solve these problems in order to really move ahead. And if you want to go to the next slide, please. And the idea was to really try to transcend the DSM and ICD with new aspects of research. And the idea is that RDoC is a research framework to help us understand how we can move forward. It is not at all intended to be another nosology as such, but rather a research framework to inform new nosologies in the future. And so RDoC is composed of a set of principles for research. And to introduce this idea, now that we are in fact 44 years past the DSM-3, we have these tools for validity, such things as all aspects of neurobiology, including circuits, genetics, and so forth, much better quantitative measurement of behavior, computational aspects, and so forth. And so we have the tools to move forward, and we're starting to implement those. Next. And we now know that pathologies are discoverable that are based in contemporary science. And by pathologies, I don't mean the specific diagnostic categories that we have now, but rather the very specific kinds of pathologies that we can discover as we learn more and more about the brain and how it implements behavior and how that relates to how people feel and behave in their everyday life, either in health or in illness. So next. Thank you. And so what this involves is a translational perspective where we don't try to say, here's a disorder, but rather to say, we're going to start thinking about all of the other areas of medicine where we consider normative functions and how things go wrong from these normative functions. In this case, because basically the brain evolved to support behavior and functioning, we need to look at the normative functions as they are based on constructs of observable behavior and the related neurobiological measures that implement that behavior. And we keep getting more and more knowledgeable about how all of these things work. Next. And the idea here is in some ways to invert the usual clinical assessment. Rather than saying, okay, this is this disorder, what's wrong? Rather, we try to say, let's look at the specific dysfunction for a given patient in terms of deviations from normal processes. And what is going wrong here? This allows us to have a very direct translation from our normal functions and how we understand those to what is going on with a group of patients who all have a very specific kind of pathology. In doing so, this allows us to align with non-human animal studies. We've known for a long time that animal studies generally don't work very well if we try to say this is an information about schizophrenia, autism, whatever, because these are so heterogeneous and so forth. But if we have these very specific aspects that are going wrong, then we can actually use these things. And we have had quite a few basic scientists and clinical scientists talking about the idea that this is very successful because it can really make this happen. Next. And finally, again, the final aspect of RDoC's set of principles is the dimensional approach, not simply looking at different ranges of psychopathology, that is the severity of a disorder, but look at the full range of variation in functioning from normal to abnormal, which helps us to understand how things might gradually be getting worse until we can decide that at some point we may need to call this a disorder. But again, like blood pressure or something, we can change these cut points at various times as we gradually get better outcomes, and to say, okay, we need to say that something needs to be changed a little bit to do a better job of treating people and having them get better. Okay, next page. Thank you. So In order to do this, we have a number of approaches, new approaches to studying dysfunction in this way. First of all, it is very important, obviously, to have reliable and valid measures of the various components involved with this research. We need to be able to have valid measures of behavior, of how brain systems work, and so forth. And at NIMH, we have actually been doing this pretty much since the time we started with RDoC. We've had a number of grant applications and opportunities for measurements this way, and looking at all the people in the field working on this. Also, starting at about the same time, really, of RDoC, not entirely a coincidence, we have seen computational neuroscience coming to the fore. You heard a lot about this yesterday, and so I don't need to add much, only to say that in our perspective, we have both very important aspects of computational neuroscience. First, models for functional constructs, the way we can use models of behavior to set those up and then run the studies to say, does this look at the way we hypothesized, or do we need to tweak this a little bit to make it right so we have much better ideas about behavior? And also clinical phenotypes, again, as you heard yesterday, about how we can look at very precision psychiatry kinds of phenotypes getting more accurate than our current symptom-based diagnostic classes. Also, that you might notice that is why I termed this computational neuroscience rather than computational neuropsychiatry. Nothing against computational psychiatry, but we really need to understand the basic neuroscience and behavioral neuroscience to help take this and translate it into pathology. Also, we have new study designs to support this idea. Next. The first is something that we just had a discussion about in our first session this afternoon, and this is looking at transdiagnostic samples. For instance, as opposed to saying we are only studying schizophrenia or only studying bipolar disorder, we might look at groups of the whole psychosis spectrum, or a mood anxiety spectrum, or the childhood spectra of different things. And there are very interesting writings now about, for instance, in childhood, that this is not even something just about childhood psychiatric disorders, but other related, very much related and cross-cutting problems in terms of learning disabilities, motor skills, and so forth. So this is something that we think, again, we can understand what's going on with looking at a bigger sample than simply one diagnosis. Again, in terms of research, we still don't know how this might eventually transcend into different ways that we actually have new disorders altogether. That's way in the future, but that's where we are trying to get. Next. It's also important to consider looking at alternative independent variables. We almost always look at patients with a given diagnostic class, or perhaps different kinds of symptoms and group by symptoms. But it may be useful instead to group a given sample for a particular study in terms of different kinds of circuit activity, or a dimension of task performance, genetics, and so forth. And this really helps us to look at a different perspective and understanding of how we relate all these information sets together. Next. And it is very important, of course, to have development and environment in study designs. This was relatively early in the RDoC development because we were so busy simply describing the constructs and how the whole thing was organized. But as people have become able to understand how our original framework was set up, we have been encouraging more and more the need to look at development, especially through childhood and adolescence, but for the lifespan. And also there are new ways of looking at environmental influences that are also very helpful. Next. And so looking at the RDoC framework, there are 4 major elements that we have. And this is set up here. And you can see that framework with 4 circles. And on the right, the blue background is related to the blue circle on the left. So this is about functional domains, again, with foundations in basic biobehavioral science. And you can see those 6 different domains: positive valence, social processes, cognitive processes, etc. And each of these domains has several specific constructs within those domains, which have been validated by workshops that were created early in the 2010s, 2011 through 2013, to really look at validated data that were devised again from both basic and clinical scientists. Also, we like to look at studies that have multiple integrative measures. As you can see, the icons represent genetics, molecular and cellular aspects, brain circuits, behaviors, like the running is just a depiction of all our different kinds of behaviors, and the pen there representing all different kinds of questionnaires and symptom scales. Also, as I mentioned, we put great importance on lifespan development. And finally, environmental influences, again, with the icons looking at all different kinds of environments, neighborhoods, social environments, natural environments, culture, and so forth. So next to that. And that's the environmental influences. And we are putting an increasing amount of importance on social determinants of health. Next. So one of the things that is really important for this, I think, for all of what we're trying to do, is to integrate various types of measurements to really get a comprehensive understanding of what's going on. If you can do next, then this is sort of one, let's say, just as one example, potential threat, which is one of the constructs in the negative valence domain. People think about dimensional potential threats different ways. Next. For instance, many people will express this in terms of symptoms and language expression. And that's an obvious, understandable approach. However, others say, well, we need to look at the genetics and the brain systems of how potential threat or fear, to use a commonplace term, actually makes all of this happen. And that's what's really important. And we certainly have lots of people who are very reductionistic and only want to have that perspective. And then on the other hand, once more, others have a big emphasis on cognitive and behavioral functioning. And certainly for potential threat or fear, the extent to which you run away or how you react to fear things is very important. But so often we don't put these together. And often because we have tried to put together our best ideas about these things, they don't all match up. We may have something like fear, but fear remains a rather complex and hard to understand term, even though we think fear, yeah, we know what fear is. And so what we really need to do is to understand the relationships between all of these aspects and others with actual quantitative data. Next. So in other words, we need to actually have studies that look at the relationships between these things, and then we can get a better idea of how we think about what these things are, what brain and behavioral systems do, and so forth. Next. And again, looking heavily at environments and social determinants of health. So for instance, it's becoming increasingly known that PTSD is very different if you have someone coming in with one very threatening or traumatic event versus people who have several or many traumatic events. The actual brain systems, genetics, and so forth, behavior, all of those things are very different depending on the number of and severity of traumatic events in the environment. Next. Next again. So I'd just like to give you a couple of examples in this short time to just give you a sense of how these things actually could work in practice. This is a study in anxiety disorders with multiple dimensions and a very multiple sample of patients. Essentially, it was from an anxiety disorder clinic in which almost all patients with an anxiety disorder or depression came in for treatment. And often, almost always, they had 2, 3, or 4 more other disorders as well. This was extremely comorbid. If you could move ahead. Essentially, this is a sample in which patients were imagining the fearsome events that they had encountered, or in some cases, imagining standard events. And while they were imagining those things, there was a sharp noise blast, like a static blast, that makes someone blink. And when you blink, you have an event-related potential that indicates that response. And that amplitude of that event-related potential varies across people. And you can see there 5 different quintiles. And what the investigators did was to simply combine all of the patients, no matter what anxiety disorder they had, as the primary disorder, and simply dump them into one batch and then sorted them by those with the largest down through the smallest event-related potential in 5 bins or quintiles. Next. And this just shows those 5 quintiles in a bar graph with the smallest amplitudes on the left and the largest amplitudes on the right. And you can see a control group in the black bar there were actually just in the middle. And so you had patients that, according to a control sample, were blunted and others who were very hyperreactive. So how did this relate to anything? Going down to the next data point. So if you look, this looks at the startle ERP quintile, and this looks from, again, the very lowest startle group was on the left, and the right, this is on the x-axis, and the largest hyper ERP was on the right. Now, if you look up in the bar graph above that little box in the lower left, these are the mean questionnaire scores. One might think that those with the largest ERPs would be the ones who have the most symptom reports. And in fact, it's just the opposite. Those with the most blunted startle ERPs are the ones consistently for almost all of those various measures, the Beck Depression Inventory, trait anxiety, and so forth, that are the largest, and going down to the most non-problematic measures for those with very large responses. And what's interesting also, now going to the next one, is that if you look at, in fact, the proportion of the different diagnoses, on the bottom are ranked or listed the actual primary disorders: panic disorder, mood disorder, PTSD, and so forth. So roughly speaking, if you look at the left part of this graph, the diagnostic categories are those with more of an anxious, anxiogenic kinds of issue: panic disorder, mood disorders, generalized anxiety, and so forth. On the other hand, on the right-hand side, you can see the larger startles with people having like specific phobia, adjustment disorder, OCD, and so forth. So to some extent, it kind of represents a worrisome problems versus just fear problems, but yet it's not one-to-one. And so this might give us a much better specific understanding of an individual patient rather than looking at a diagnostic class. Okay, that's one example. Now we'll go to a couple others. Going actually to trials now, RDoC has been involved with some trials, and others who didn't start that way, but worked out in terms of trials. And here we are looking at not simply an RDoC idea per se, but the idea coming across all of the ideas for clinical trials is that if we want precision trials, we need to look at tests of mechanism to really understand exactly what is happening, very much comporting with ideas of biomarkers and exactly what they represent. And so if we get these tests of mechanism, we can look at potential therapeutics. So the idea is that with an intervention, we need to look at target engagements where we understand specifically what the treatment does and then see how that relates to outcomes. Next. So in terms of RDoC, the selection criteria is not to pick, again, a single diagnostic class, as we've been discovering, but to actually select patients on the basis of a measurable impairment in a specific function. For example, high or low fear reactivity, just as I showed you in the prior slide, or working memory, whatever. And just as the last slide, these are often transdiagnostic. Next. And so likewise, the outcome measures are likely to be based on very quantifiable functional improvement with respect to the specific function. Next. But of course, as well as self-reported symptom relief. This is not being left behind. That's obviously another thing that is something that is very important to look at. But the idea is that often the functional improvement will help us improve the symptom relief. And for example, if we want to look at functional improvements, we could look at the examples for both the EMA and FDA over the last decade, considering cognition as an indication in major depressive disorder, which actually follows the matrix battery in schizophrenia that started off in the early 2000s. Okay, moving on. So just to show you a couple of possibilities here in the next slide. This is the exact study that Wayne Drevitz reported yesterday, so I don't need to go into this in great detail, but this was the FAST mass study that actually was a contract under the RDoC program early on when drug companies started to leave the psychiatric space and going on to other disorder classes like cancer and so forth, which had better targets. And so we said, well, we really were not planning on this, but we maybe should look at how RDoC ideas could contribute to how this might work. And so this was a contract for mood anxiety patients. And the idea was, again, as you heard, to look at patients specifically which had high anhedonia levels of SHAPS of over 20, and to look at that grouping, both with patients either mood or anxiety. And the event, it turns out, for whatever reasons, that most patients with anxiety either didn't feel like they wanted to participate or they weren't worried enough about anhedonia, so forth, so that it became mostly mood patients, although not 100%. And so, as you heard from Wayne yesterday, this was the idea that a kappa opioid blocker actually increases the ventral striatum activation on a reward task, the monetary incentive task. And so this is actually, I don't think that Wayne actually showed the bar graph on the right, but it showed that at the baseline, both the J&J compound and placebo had exactly the same fMRI intensity. But after the treatment with the kappa opioid blocker, you can see a very significant difference between the J&J compound and placebo. It's quite frequent that in something like this, where you have an original baseline and then a subsequent treatment, that the placebo actually shows somewhat less intensity simply because it's a repeating paradigm, and so there's a little less just response overall. But you can see there was still that increase for J&J. And as Dr. Drevitz mentioned yesterday, this event, even though it was looking mostly, this was the heart of what people thought was the critical data for this trial, this phase 2 trial. Just, do we get an event changing something in the brain that we think could then prompt something that is good and mitigate the problems with the actual symptoms. And as we know, that happens. But this is where we think is really important to know, okay, we actually have this effect. And so that was something that has now gone, as Wayne said, into phase 3 trials with a couple of different drug companies. Next. Another study is called the Bipolar and Schizophrenia Network for Intermediate Phenotypes. And you can go next to put up the slide there. So this is a slide with that represents a large experiment with over 400 people, originally sampled from patients with either schizophrenia, schizoaffective disorder, and psychotic bipolar disorder, finding relatively little differences among these three diagnostic classes. All of the patients were grouped into one large class called psychosis. And then, given that the investigators had gathered a large number of data types, they did a factor analysis to say, okay, what are the factors actually for these patients that are the most strong representational data. One was called cognitive control, which meant essentially cognitive tasks plus a cognitive control task. And the other was something called sensory motor reactivity, which was the amplitude of EEG and ERPs, both in response to specific stimuli or in anticipation of stimuli. And after getting those two factor analyses, they looked at the factor scores. And if you look in the upper right there with the little graph that shows red, green, and blue scatter plots, those represent clusters that were computed from that space with dimensions of cognitive control and sensory motor reactivity. If you look down in the lower left, then here are the three clusters, or as they termed them, biotypes. The first biotype is a group of patients with very poor cognitive control, poor cognitive performance, and very blunted EEG activity. Before I go farther, I should say that these groupings were represented by all three of those diagnostic classes in each of these biotypes as well. A slight increase in patients in biotype 1 and somewhat of a more in biotype 3, which I'll get to, somewhat more bipolar disorder, but actually well scattered for all of these diagnostic classes across the biotype. So this was truly a transdiagnostic data set. So second, the biotype 2 was also very impaired, almost as badly impaired with cognitive control as biotype 1. But if you look at the little squiggles above that little brain representation, you can see they are very highly amplitude EEG and ERP for biotype 2. And biotype 3, on the other hand, actually had cognitive control that did not really differ significantly from control patients in the study. And the same was true for their EEG activity. So they were pretty much looked normal, but yet they still met criteria in terms of symptoms for one of those three diagnostic classes. Next. Now, how does this react to something very specific? Well, they looked at the cognitive control and sensory motor reactivity biotypes and found that there was one very interesting clinical trial. Next. It turns out that clozapine increases the EEG activity and so this was something that is of interest for patients with blunted sensory motor reactivity. The intrinsic EEG activity, or IEA, is this term that they used for this dimension of the sensory motor reactivity from very blunted to very hyperactive. And so finding that clozapine increases the intrinsic EEG activity, this looked like an opportunity to look at patients in biotype 1 who had such blunted IEA. Theoretically, this should actually increase that activity and perhaps then help and make patients better from a lot of aspects, to be determined, because it's surely going to be better, but one doesn't know exactly how. On the other hand, if you presented clozapine to biotype 2 for patients who already had very hyperreactive intrinsic EEG activity, that could be actually iatrogenic. and to an extent for patients with biotype 3 as well. So this is a very specific trial that the investigators are looking, and they're coming close to actually finishing the sample and looking at the data. But this is another example of how very specific aspects, not just simply diagnostic classes, can work. I also want to mention, as I go into the last slide for this talk, that these dimensions are very important, because we don't think of those kinds of dimensions in any of these diagnoses, but yet we have these new ideas that are very important, that lead us in many new directions for how to look. So in concluding, what are the new directions here with RDoC? First, the idea is to shift the discovery paradigm toward basic functional dimensions based on relationships among neural systems, behavior and cognition, symptoms, and so forth. Next, for diagnosis and treatment, the idea is to move from these heterogeneous syndromes to focused assessment and intervention based on specific functions and mechanisms, and again, as a research framework to understand how this can work. Third, to employ computational neuroscience increasingly and with large cohorts for models of brain behavior relationships and classification algorithms. And finally, next, again, to overall accelerate progress with the idea that precision interventions can result from precision diagnostics. Sorry about the little TP at the end. I'm not sure where that came from. And the final slide then, this final data point. This is a quote from a former NIMH director, Steve Hyman, who wrote a very compelling essay a few years ago with the conclusion that modern studies are consistent with psychiatric disorders as heterogeneous quantitative deviations from health. Thank you very much.
Thank you very much, Bruce, for this impressive overview. You started by saying you're proposing to transcend DSM, but you really took us through a journey towards the reinvention of how one should study dysfunction, and you showed us some very practical examples of how it is being done. Unfortunately, we are running about 40 minutes late at the moment, and so unless there are burning questions again to any of the three speakers in the last session, and I'm having a careful look both in the room and online, but if there are none of those, I would really like to turn to our co-chairs, Marion, Andy, Martin, Brenda, for their final remarks. But before I do so, I would also like to express the appreciation of all of us in the room to the four of you for putting together a very unique and impressive program. We've been on a genuine intellectual journey and scientific journey over the past 3 years, and we owe you a great deal for that.